Hello class, this is our new topic, the inflection point. And before we discuss the inflection point, first we refresh our previous topic, which is the tangent line and the normal line. In this case, from the graph, we have the tangent line which is found in the upper part of our curve. And also here, this is the tangent line which is touches to the curve. Also here, and also the lower part of the curve. This is the minimum part and also the maximum part. Also, we have the convex and concave. The concave upward and concave downward. So now we found here an inflection point. What does it mean? The inflection points are the points at which the curve changes from concave downward to concave upward or vice versa. An inflection point, the second derivatives of the slope is 0. To get the inflection point of the curve, find the second derivative of y or the original equation of the curve and set y double prime or the second derivative to 0. Then get the values. For example, find the inflection point of the curve y equals to x cubed plus 3x squared minus 2. So we have the solution. From the equation of the curve, first we find the first derivative, which is 3x squared plus x or 6x. Then we set the first derivative to 0 to get the values of x. From 3x squared plus 6x, we find the value of x 0 and negative 2. So we have two values of x. We call it x sub 1, x sub 2. Then also we get the values of y, which is y sub 1 and y sub 2. These are the critical values for the maximum and minimum of the curve. This y1 and y sub 2 is found also in original equation of the curve, which is we relying all the values from the equation of the curve. So we plug in first the 0 to the equation of the curve. So we find the value of y equals to negative 2 and also plug in the negative 2 into the equation of the curve. We find the values of y sub 2 equals to 2 because we need these critical values graphing the curve. For the inflection point, we need to get the second derivative, which is 6x plus 6. Then set the second derivative to 0. We find the values of x equals to negative 1. And also, we need to find the values of y. From the equation of the curve, we plug in the negative 1. We find the values of y equals to 0. So we have the inflection point is equals to x negative 1 and y equals to 0. If we use that values into a curve, first we use the critical values. What is the critical value? The 0 and negative 2. So from 0 to negative 2, 0 the value of x and negative 2 values of y. Something here. This is 0 and negative 2. And also the other critical values is negative 2 and positive 2. Somewhere here. This is 2 and negative, negative 2 and this is 2. That's negative. And if we continues to solve for the graph, we form a graph like this. Change this graph. Because we have the inflection point is negative 1 and 0. So somewhere here. So we need point this graph in here, the values of here. So this is the inflection point, which is negative 1 and 0. This portion where the curve changes from concave downward to concave upward. So that's the inflection point. Another example, find the inflection point of the curve y equals 2x cubed plus 5x squared minus 3x minus 4. We have the solution. Same procedure as the other example, y equals 2x cubed plus 5x squared plus 3x minus 4. And first we find the first derivative. So the first derivative is 3x squared plus 10x plus 3. Then we set first derivative to 0. Then find the critical values of the curve. Negative 1/3 and negative 121 over 27 and negative 3 and 5. It's two values of x and two values of y. For inflection point, from first derivative, we need to get the second derivative, then set to 0 to find the values of x, which is negative 5 over 3. After finding this value, we need to plug into the equation of the card to find the values of y. So we have x equals to negative 5 over 3 and y equals to 7 over 27. That is the inflection points. So we need to use this in a curve. First, the critical point is 1/3. So somewhere here, if this used as 1 value or use this as 1, this is 2. Need to change the range. So if x is negative 1/3, we assume here, and 121 over 27, that is 4.5 That is 121 over 27 is somewhere here. 1, 2, 3, and 4 is somewhere here. And also the negative 3 and negative 5. So 1, 2, 3 is 1, 2, and 3, and negative, and 1, 2, 3, 4, 5 somewhere here. We use this is negative 3 and 5. This is negative 3. And the critical point, 5 over 3 is 1.667 in decimal point. 1.667, so somewhere here. And y is 7 over 27. That is 0.26. So 1.67 is somewhere here. So if we continue this graph, we have here, this here, and here. So this is negative 1/3 and negative 1/21 over 27, and this is the inflection point, negative 5 over 3 and 7 over 27. So that is the inflection point where the curve changes from concave downward to concave upward. So that's our example. Thank you very much. I hope you learn in this topic.